Why were early network protocols so complex for interoperability? Imagine trying to get to people speaking different languages to understand each other. That's similar to what early network protocols faced when connecting various computer systems. Back in the early days of digital communication, there was no single standard everyone agreed on. Different networks used different hardware, methods, and rules to send data. This made direct communication a real challenge. Most networks operated independently with their own protocols, kind of like separate countries with their own languages. To connect them, researchers looked at two main options. One was creating a common protocol that all networks would use, but that meant changing existing systems, which was costly and complicated. The other was using gateways, special devices that translated messages between different protocols. This approach added layers of complexity, because each gateway had to understand and convert between incompatible systems. Then came the development of the Transmission Control Protocol and Internet Protocol in the 1970s. This suite of protocols introduced the idea of open architecture. It meant networks could connect through standard interfaces and rules, making communication easier. The Transmission Control Protocol made sure data was sent reliably, while the Internet Protocol handled addressing and routing. Together, they allowed data packets to travel across many different networks seamlessly. But this system was layered and detailed. It had to manage many things like addressing, routing, error detection, and data integrity. Each layer added complexity but was necessary to ensure data could move smoothly across diverse systems. Early protocols also had to deal with technical issues like different link speeds, packet sizes, and data fragmentation. These added more layers to handle data traveling reliably from one network to another. The complexity was also influenced by the competition during the 1970s and 1980s. Different standards, like the Internet protocols versus the Open Systems Interconnection model, created what's known as the protocol wars. These debates led to more layered and adaptable designs, but also made protocols more intricate. In practical terms, these protocols had to connect research networks, government systems, and later commercial networks, each with their own needs. This diversity meant protocols had to be comprehensive, which naturally made them complex. Yet, this complexity was necessary to build the foundation of the modern Internet. The development of TCP/IP and open architecture networking marked a turning point. They overcame the challenges of connecting different systems and set the stage for the global digital revolution we experience today.